Today we jump ahead to section 8.1. There are a couple more sections in chapter 7, and we will circle around later and come back to those. But it makes more sense to me to go ahead and jump to 8.1, something called factoring. I know at some point in your life you learned what factoring means, at least if you're dealing with numbers. For example, I might ask you, factor the number 24. What does that mean if I ask you to factor the number 24? What times what will equal 24? That's exactly right. So what times what will equal 24? There's lots of right answers. One correct answer is 6 times 4. Another is 2 times 12. Another is 1 times 24.
3 times 8.
3 times 8 is another correct answer. There's more correct answers. We're not done yet.
Twelve
12 and 2, 2 and 12, same thing really. Just switch the order. 4 and 6, well, we've got 6 and 4. Same thing, just switch the order. How about...
12 squared.
No, 12 squared would mean 12 times 12. That'd be 144. How about 2 times 3 times 4? Is that a correct answer? Yeah, nobody ever said you can only use 2 numbers, right? Factoring doesn't mean just use 2 numbers. You can use more.
It's like the factor tree.
Yeah, that's what I'm getting towards, is the factor tree. So the best answer is actually 2 times 2 times 2 times 3. That's the best answer. Why is that the best answer?
The lowest one.
What do you mean by lowest?
Oh, everything's prime numbers.
Everything is a prime number. There's the words I'm looking for. What do you mean everything is a prime number?
Can't be.
Only multiply by itself and 1 to get there?
Right. The only way to break down 2 is to write it as 1 times 2. And the only way to break down 3 is to write it as 1 times 3. This is called the prime factorization. And that's the most important one. When you're dealing with numbers and you're asked to factor, you almost always want to find the prime factorization. And quite often this would be written as 2 cubed times 3. You'd see it written that way too. Well, what we're going to do in this section is we're not going to factor numbers, we're going to factor polynomials. Sounds great, doesn't it? Oh, yeah. And this is why we taught you how to multiply. So let's look at a multiply problem first. What if I asked you to multiply x plus 3 times x plus 5? What would you do? You would go ahead and distribute. And you'd have x times x. X times x is x squared. X times 5, 5x. 3 times x, 3x. And finally, 3 times 5, 15. And then what would you do? Combine your like terms. So you would have x squared plus 8x plus 15. Now, what I want you to notice the numbers we started with. We started with a 3 and a 5 as our numbers. And when we did our multiplying, we ended up with a number 8 and our number 15. How are 8 and 15 related to the numbers we started with, 3 and 5? So this number 8 right here, this is 3 plus 5. And this number 15 turned out to be 3 times 5. That's exactly correct. Is that just a happy coincidence? No, why not? That's what we did. How do you get the number on the end? Well, the number on the end always comes from multiplying these two numbers. And then how did we get the 8? We multiplied on the outside, we multiplied on the inside, and then we added. That's how we got the 8. All right. So what factor means, to factor means we would start with x squared plus 8x plus 15, and you would tell me what two things do you need to multiply together in order to get x squared plus 8x plus 15. That's what factor means. So it's kind of like playing Jeopardy. Before I gave you two things and I told you to multiply them together. Now I'm giving you the answer and saying you got to give me the two things.
And it's starting backwards.
Yeah, it's going exactly backwards. That's exactly right. Well, we know the answer. The answer is
X plus 3 and X plus 5.
x plus 3 and x plus 5. We know that has to be the answer because it's the same problem we did before. All right, so let me change the problem a little bit. What if I said factor? How about x squared plus 9x plus 18?
X plus 3, X plus 6.
And how did you get x plus 3 and x plus 6 so incredibly fast?
I just figured out what two numbers would add together to make 9 and then multiply together to make 18.
That's exactly right. So what you're looking at is, I always start with the 18. I need two numbers that are going to multiply to be 18. But then at the same time, when I do this FOIL thing, when I multiply these together, I also need those two numbers to add up to be the number in the middle. So I need to find two numbers. When I multiply them together, I get 18. And when I add them together, I get 9. So what two numbers add to be 18, or add to be 9 and multiply to be 18? 6 and 3. Does it matter if I put x plus 6 first or x plus 3 first?
Let me ask you.
I don't think so.
Does the lowest one always go first?
Doesn't matter.
Doesn't matter. Okay.
If I want to write x plus 6, x plus 3, that's okay, because that's exactly the same as x plus 3, x plus 6, because I'm multiplying. If I'm multiplying, I can switch order any way that I like. Okay, questions on that one? All right, how about, I don't know, x squared plus 11x plus 30. Don't shout out the answer, but rather tell me what you're looking for. You need two numbers to do what?
Numbers that multiply to come to 30,
They need to multiply to be 30.
and then they both numbers need to add up to become 11.
They need to add to be 11. Okay, so would I use, for example, 3 and 10? 3 and 10 multiply to be 30. Is 3 and 10 a good choice? No, why not? 3 and 10 don't add to be 11. So 3 and 10 is not the right answer. What is the right answer?
6 times 5.
6 and 5 is the right answer. 6 times 5 gives me 30. 6 plus 5 gives me 11. So the right answer would be x plus 6, x plus 5. And again, if you wrote x plus 5, x plus 6, that would be fine.
Is MathLab going to be picky about what order we put in?
No, MathLab is not picky here. It will allow either order. That's a good question. All right, now, these get a little bit harder when you start to have minus signs floating around. So let's try x squared minus 2x minus 24. So what happens now? I need the two numbers to multiply. What do they need to multiply to be up to?
4.
They need to multiply to be negative 24. And they need to add to be what? Negative 2. Okay. So how can I get a negative 24?
If we multiply negative and positive?
Right. So for example, I might use negative 8 and positive 3. If I use a negative 8 and a positive 3, do they add to be a negative 2? No, so negative 8 and positive 3 is not the right combination. Negative 6 and positive 4. Those multiply to be negative 24. And when I add them, negative 6 and positive 4 does give me negative 2. So it has to be x minus 6 and x plus 4. Now, notice here the minus signs do make a big difference. If you were to give me x minus 4 and x plus 6, would that be a right answer?
No.
No, why not? Because you get positive 2 in the middle when you add those together. That's right. So, when you have pluses and minuses, again, it doesn't matter which order you write them in. I could write x minus 6, x plus 4, or I could write x plus 4, x minus 6. The order doesn't matter, but it is very, very important which one has the minus sign and which one has the plus. So this is a wrong answer.
So even if it doesn't matter, if one's a minus, one's a plus, you can still put them in whatever order.
Correct. The order doesn't matter. What matters is the 6 has to be the one with the minus sign, because I need a negative 6 and a positive 4 to get that negative 2. That's what matters. The signs matter. Questions on that? All right, let's try another one. How about x squared plus 5x minus 14. X and x. This time I need to multiply to be negative 14 and add to be 5. Can you think of a couple of numbers that will multiply together to give you a negative 14 and add together to give you a positive 5?
Positive 7, negative 2.
Positive 7 and negative 2, I think, will fit the bill. I think that's exactly correct. Questions on that one?
I have a question. If you're not, let's say that I don't know quickly on what numbers to put in, is there an easy way to find?
Yep, I know what you mean. Here's what I do. Let me give you another problem here. Let's say I gave you x squared plus, I won't change it much, 5x minus 24. Here's what I tend to do, and I find this to be helpful, especially if the numbers are bigger. What I tend to do is I tend to take the number 24 and say, let's see, that can be 1 and 12, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then I look at all the pairs and I ask myself, is there any one of them where I can use that I can get a 5 in the middle? Is there one that I can use to get a 5 in the middle? Yes, it's plus 8 and minus 3. Again, you got to check your signs there. So it has to be x plus 8, x minus 3. And like I say, this is useful if these numbers are bigger. And if these numbers are bigger, I really tend to grab my calculator and start taking my calculator, and I'll go, whatever the number is, divide by 2. Whatever it is, divide by 3, divide by 4, and just make a list and see if I can find the one that gives me the number in the middle. Okay?
Will you give us one with decimals in them?
No.
Okay.
Great news. We will not have decimals and we will not have fractions. Oh,
Stop it.
not in this section. Not to say never, but not in this section.
Never.
All right, how about this one? I haven't done one like this yet. How about x squared minus minus 10x plus 24. So I don't think I've had one yet where I have a minus in the middle, but I have a plus on the end.
Negative 6 and negative 4.
Correct. Now it's going to have to be two numbers that multiply to be 24 and add to be negative 10. And the way that works, if you're going to multiply to be a positive number and add to be a negative, they both have to be negative. So that one's an x minus 6 and an x minus 4. Questions on that one? All right, here's a good one. X squared minus
5x plus 12. Silence. I found the hard one finally.
Well, what needs to happen? We need two numbers. They need to multiply to be 12. And they need to add to be -5. All right, so give me two numbers that multiply to be 12 and add up to be -5. What are the answers? I'll give you a hint. It's a trick question.
There is no answer?
There is no answer, is there? What's the only way you can get the number 12? 12, we could do 1 and 12. We could do 2 and 6. We could do 3 and 4. Is there any way to get a 5 out of any of those pairs? No. It can't be done. So what's the answer?
Undefined.
Not undefined. Not 0.
Impossible.
Not impossible. Cannot factor. And what do we call something that cannot factor? Prime. Just like we have prime numbers, sometimes we have prime polynomials. And this is an example. So your answer for this one would be prime. It does not factor. Of course, you could write does not factor if you wanted to. That would be a correct answer too. But typically we just say prime. And that can happen. Just like some numbers don't factor. The number 13 doesn't factor. Polynomials sometimes don't factor. And we simply call them prime. Those usually bother people more than any other question. Because I'll say factor. And they're convinced there's got to be a right answer. And they'll try, and I'll see people spend 10 minutes on that problem. And the answer is you can't do it, it's prime.
I'm just confused. If you're adding -6, and this is the last question. If you're adding -6 and -4, wouldn't that be a positive 10?
No. When you add two negatives,
If you have a -6 and you're subtracting 4 from it, that'll be -10.
no, that would be -2. -6 minus -4 would be -6
No,
plus 1.
I was saying -6 minus 4.
All right, so here's a nice thing about factoring. You can always check your answer. So this would be x squared minus 4x minus 6x plus 24. What's minus 4x minus 6x? -10x. That's the wonderful thing about factoring. You can always check your answer real quickly. Just multiply them together and see if it works. Yeah, just there a little bit. Okay? Anyway, watch out for the prime ones. Those are the ones that just freak people out. They try and try and try. They're convinced there's got to be an answer. There isn't sometimes. Okay, the last thing in this section. Do you remember yesterday, well, Monday, whatever, last time we met? Every now and then, we multiplied problems like this. We did some here as homework questions just a minute ago. What happens when I multiply two things together where they're exactly the same except one has a plus in the middle and one has a minus in the middle? The middle two terms cancel out and we end up with what? The 2 on the end. And something else happens. You get nice numbers here. Really nice numbers. 9x squared minus 4. 9 and 4 are really nice numbers. What do I mean by really nice numbers? Not prime. In fact, what's the only way you can factor the number 9? 3 times 3. It's a perfect square. And 4 is 2 and 2. So, going backward, factoring, here's what we're going to look for. If we had, for example, 25x squared minus 16. I noticed that there's only two pieces. What had to happen to only end up with two pieces if I were doing multiply. Well, what had to happen is the middle two had to cancel each other out. How did the middle two cancel each other out? One was negative and one was positive, and both of these numbers have to be perfect squares. Is 25 a perfect square? Yes, it's 5 squared. Is 16 a perfect square? Yes, it's 4 squared. So how does this factor?
5x minus 4, 5x plus 4.
5x minus 4, 5x plus 4. And again, the order wouldn't matter. If you wrote 5x plus 4 and 5x minus 4, that would be fine. All right, here's another one. How about 81x squared minus 9, not 9. 9's a bad number. How about 64y squared? I look at it. Again, I notice there's only two terms. Are these both perfect squares? Yes, 81 is 9 squared and 64 is 8 squared. This one's got an x and a y in it, though. How's that going to change things? It doesn't a whole lot. What's my answer going to look like? 9x minus 8y and 9x plus 8y. That's how you get the y squared. You just put a y on each of these ends. Really nothing different. Just got to add an extra number. Questions on that one? Okay, last one for me, and then I, as usual, have some for you. How about 25x squared plus 36? Five x
Plus 6.
and 5x minus 6. That's close. That's not the right answer.
Plus 6.
5x minus 6 and 5x plus 6 is not the right answer, because a minus 6 and a positive 6 is going to give me a negative 36. So that's not the right answer.
So net, so plus 6, 5x minus 6, 5x.
5x plus 6 and 5x plus 6? That's not the right answer. Why not?
Then you have one with an x in the middle or a single x.
The middle two are no longer going to cancel out.
60x or something.
I'd have a 30x and I'd have another 30x. That would be 60x. The middle two don't go away anymore.
What if the absolute value of 5x minus 6?
No.
Can't be both negative. 5x minus 6, 5x minus 6.
If they're both negative, the middle ones still aren't going to cancel out, are they? Prime is the right answer. That is correct. All right, so be very, very careful. This formula that we used where the middle two cancel out, in order for the middle two to cancel out, that's got to be a minus in the middle. If you have a plus here in the middle, it's not going to work. Try as hard as you want, you're not going to be able to find an answer. It will be prime. So watch out for that. That's another one that will almost always catch people. It's so close. 5x minus 6, 5x plus 6 almost works. 5x plus 6, 5x plus 6 almost works. They're so close. It's so tempting to say there's got to be a right answer. There isn't. It's prime.
Just a question, wouldn't the absolute value actually work? Should the absolute value be the entire problem?
No.
How would that not be?
If you have the absolute value of 9 minus 4, that's not the same as 9 plus 4. What's 9 minus 4? 5. What's the absolute value of 5? 5. What's 9 plus 4? It's not 5, is it? When you have things added together and you have absolute value around them, the absolute value doesn't just make each one of them positive. Absolute value doesn't work that way. Absolute value is a parenthesis. You've got to do inside the parentheses first.
So what is the absolute value of the whole problem? So you did absolute value 5x plus 6 times 5x minus 6, absolute value.
All right, so 5x minus 6, 5x plus 6, absolute value of the whole thing. That would be absolute value of 25x squared minus 36. But again, unfortunately, absolute value doesn't allow me to just change that to a positive. Doesn't work. Absolute value doesn't work well dealing with adding and subtracting. Only with multiplying and dividing.
This is going to be on our
No, there will be nothing with absolute values in this section on your math lab. He just asked if that's the right answer, and I said, no, it's not. You have to explain why it's not the right answer. So no, you don't have to worry about that at all. What you have to worry about is, if you have two pieces, and you've got a plus in the middle, it's not going to work. It's prime.
And every time I see a 25 or a 36, I'm going to want it.
Every time you see a 25 or 36, you're going to want to write an answer. That's correct. I agree.